Hey gang, welcome back to Inverted Pursuits Laboratory, and this week we're starting a new project here on the channel. So I decided I wanted to start working on my level 3 certification launch. There's a lot that goes into that. I'm currently level 2 certified. I flew pointy end up. There's a video on the channel you can look at for my cert flight, and successfully flew that in, would have been October 2020. Yeah, October 2020 I flew my cert flight for that and got my level 2 cert. I'd previously gotten my level 1 back in, I believe, 2016 or 2017. But I wanted to start working on my level 3 here a year later, or a little over a year later, as I've started to get more comfortable with the larger rockets in the hobby. But I also do a lot of 3D printing, so I wanted to try and bring a lot of that into it, which rose a lot of questions on, could I build a 3D printed level 3? Well, turns out it's been done several times before, but I didn't want to do it like everyone else, or like what I've been doing, where I 3D print it, I screw it together, and it just works. And I love it, it works, it's great. But I also don't want to spend the like several hundreds of dollars to buy the fiberglass tubes at 5 to 6 inch diameters to fly it on a 75 or 98 millimeter motor. Probably be a 75 is what I'm currently thinking. So I wanted to do things with like 3D printed parts that I could attach and glue together, and but try and have strength through it, but also be able to use commercial off-the-shelf parts. Like I want to have a fiberglass nose cone in it with the next generation of like fiberglass AV bay that I've been working on and designing. I haven't yet to build, as well as like a next generation of like electronics AV bay, and see if I can get a fiberglass AV bay that's a lot cleaner than the ones I've produced in the past, and a lot cleaner than some of the things I've 3D printed. But this wasn't something I wanted to like do all of this testing on my first level 3. So I'm deciding to build a smaller rocket that's more in the level 2 scale to test all of the concepts I'm wanting to put into my level 3. I'm calling this rocket Festus. It's just kind of my harebrained rocket. It's going to be styled a lot like the concept art from the Dragon Festus from the Heroes of Olympus series. But this rocket will be 3D printed and fiberglass, as well as some carbon fiber in it. So I'm going to have primary 3D printed core parts to this rocket that all connect together. But then I'm going to have these carbon fiber rods, and this is a short one that goes in the upper body tube section. And I've got one shown off over here where I've got all of these holes in the body tube section where these carbon fiber rods can sit down inside of. And so I started designing and printing all of this to make sure it would test and fit. I especially wanted to make sure I got all of the fiberglass parts fitting good, because I want them to come apart smoothly. But I got these carbon fiber rods and started wanting to mess around with putting the rocket together like this. So now I've got a 3D printed part with carbon fiber rods inside, and when I shove it all together, now I've got a carbon fiber reinforced tube. It's only reinforced though from here to here. So now I'm thinking it needs to be stronger still, because like this is pretty squishy, and I'm not comfortable with how much I can deform this rocket body. And I was like, wait, I can do a fiberglass layup over the outside of this body tube. So I'm going to take this upper body tube and do a fiberglass layup over it after I glue the body tube sections together. And I've got some other parts printed as the rocket goes down. Like I've already got my AV bay, and then the next piece down is this one. Then I've got the next body tube section down, and then there's 2 more that go down the rocket. It ends up being around 6 foot tall, tip to tail. And the lower body tube section will be coming in a later video, but for the moment we're going to focus on the upper body tube section, getting this glued together, and then we're probably going to have to print a little mandrel to hold this on so that I can do the layup around the outside, and we're going to see how that does for the strength of the rocket on a prototype piece as we move forward. Okay, so I've gone ahead and taken all of these carbon fiber rods back out of the body section, and we're going to glue all of these in with CA glue. CA glue gives a very strong bond to all of this and makes things very strong. Also want to grab a small piece of sandpaper real quick and rough up the carbon fiber rods to ensure that they are not perfectly smooth so the glue grabs to them.
Sure, get down in there. And initially we're not wanting to kick all of these as we go, otherwise we'll end up with a gap because of the way the glue will actually harden between the two body part sections. So it's just enough glue to get me a solid bond. I did go through with an 1/8" drill bit on all of these holes because this is a 3mm carbon fiber rod and I used an 1/8" hole on here, and so I drilled it out to make sure everything was going to fit smoothly. So we're also going to put glue on the entire surface here to make sure everything adheres. CA glue, and the fact that this is printed out of PETG is actually a solvent weld, so it will cause some of the PETG to dissolve and permanently bond together. So really cool thing. I'm also going to put some on the tops of these since I don't really want to flip it upside down. That'll be enough to spread down as I line this up. So lining it up's kind of always been a pain in the butt. I've done several test fits of this. Wow, the whole thing went together first try. That is incredible. Always make sure you cover your CA glue before you start spraying accelerant, otherwise you will set your entire bottle of CA glue. So we'll come around the exterior.
All right, gang, so we have the tube sanded, and I've put it on a little jig I made out of some rocket stands, kind of torn apart. What we're going to do is go ahead and lay up the fiberglass on this tube. So I've got fiberglass here I was able to pick up. There's just enough of it to wrap around the entire tube twice. So I can pretty much do that all the way around, and I'll be able to put my epoxy on it. I've got a trash bag to catch excess epoxy, gloves, and a cup to put it all in and mix. So let's get going. All right, so we've now completed the layup on our test section, which I am super happy with how this came out. There's 2 complete wraps of fiberglass around the body tube, and the 3D printed core and everything is held up wonderfully. It is considerably less flexible than it was before, so like I can squeeze on it and it only deforms a little bit. I've actually gone ahead and built up the entire lower body, but you can see this hasn't been glassed yet, and see how much that deforms by comparison to the now glassed up tube that I can barely deform at all. And I've tested all of these parts now with the fiberglass nose cone I intend to fly on, and that slides in beautifully. And the electronics bay I've started to put together also slides in the back just as designed and intended. So the rocket's starting to come together. And to save a lot of time and me just gluing, I've already got the entire lower body section put together. I'm going to start glassing on this very soon, and before the end of the video it'll be completed. All 3 fins took several revisions to get right. I wanted to have the fillet pre-printed into the fin as I start the layup process. I'm going to do a layup around the entire body tube and cut slits in the spot where the fins are so that the glass will just slide past. And once I'm done with that, I'll sand everything down as smooth as I can, and then I'll be doing tip-to-tip layups on the fins. My current plan is to also do aluminum foil tape over the leading edge of the fin, as I'm going to end up flying this on a larger motor at some point, 54 millimeter 2560 in length. So like the motor will be like this long in the body tube, and it'll go around Mach 1.2 is the current calculation. A modification I did have to make very late in the game, which is why it's kind of got this odd shape at the back, but the glass will help smooth all of that in, is this little plate has 3 captive nuts in it for a thrust plate. So I'll actually be transferring all the force of the rocket through this aluminum plate and an aero pack retainer on the back end, so that even when I'm trying to fly at supersonic speeds, the entire force goes into the butt of the rocket rather than just a thin lip of cardboard that's resting against 3D printed material. I want it all the way against a giant flat 3D printed surface. I still may tear the rocket apart going Mach 1 with a 3D printed and fiberglass airframe. The combination is an unknown on how it'll hold up, but everything actually fits together beautifully. And once I get it in there, it actually is almost airtight because the motor doesn't like to fit in there. But this rocket, standing it on the floor, is, you know, a little under 6 foot tall, probably 5.5. I don't remember the exact length in the model, but it's off a little bit now since I had to add that retainer. But very excited. I've started work on design of the electronics bay, and that'll also probably be one of the next things after the body tube is glassed. All right, so apparently I lost all the remaining footage of building Festus. I was like 90% certain I filmed glassing the lower body, working on some electronic stuff. I apparently filmed none of it. So I'm gonna give you a quick breakdown of how Festus looks just before flight, which will be the next thing we get to in the video. If you're interested in just seeing the flight, you can skip ahead to the time index listed here, or hopefully I've figured out stories for this video. Don't know if I'll figure out chapters. But so Festus has a fiberglass nose cone, which has a custom integrated AV bay that I designed and printed. It's meant to work with my T3 tracker. I ended up using an egg finder in it for the first flight because my T3, I think, died on me. I mean, it refused to work in field, so I had to use the egg finder. Absolutely nerve-wracking. You'll hear me rant about that a little bit in the field. But this sled fits up inside the nose cone, bolts in place, the tip then screws on, and that retains the entire thing in there. The lower body tube, or upper body tube, sorry, which we saw getting glassed earlier, you can see it's all painted up. Festus was painted to look like a bronze dragon. Only thing still haven't done is figure out how I'm gonna paint the dragon head on this. Granted, it got quite the physical beating out in the field, getting drug across a field. The AV bay, as we're going down through the parts, fiberglass, there's a switch band that was glued on here. This switch was done in a very unique way. So Randy Milliken from Rail Buttons gave me 2 of his rail buttons to try out. Now, I love these things. They work incredibly well. I even went so far as to create switch covers for them, which didn't end up fitting in Festus the way I built this sled. If I had to rebuild the sled, I would lower where the switches sat down some and be able to build the switch covers in there, because I do run the risk of backing the screws all the way out. But it didn't fit in this version that I built. Hopefully I can get a chance maybe to build a second version of this sled before I fly her again. We'll see. It's not my highest priority right now. I've been working on other issues I found within the rocket as I was flying it. But I've got one switch for my Stratologger and one switch for my RRC3 that I'm running on the board. I did find out, this is actually the second RRC3. My original RRC3 died in a crash I had 2 years ago on a little tiny 38mm I was flying. It broke. But I was flying both these off 9-volt batteries on a 3D printed sled, and then these were actually recessed inside. So to switch them on, you actually put a screwdriver through the 2 screw holes here. Only like mistake I would argue I made on location is that this right here was my rail button. So that meant the launch rail was like right next to the switches, and thankfully I could reach them on either side of the launch rail, which was something I tested before flight because I realized my mistake, but I don't have a chance to change it on Festus. So for my actual L3 rocket, which I've got approval to start working on, we'll be taking a different route. And by approval to start working on, I mean I've got 2 taps, and I've got a lot of work to do with those 2 taps to get ready to go. But this is the full, oh, it's not the full AV bay. Then there's this chaos piece that bolts on top. And then I actually use, rather than using pop rivets or something to retain the E-bay to my upper body tube, I have I had 3 screws. One's tore out, so I'm gonna have to remake this piece at least. I've got the 2 screws here that are 632 that bolt through the sidewall of the rocket. And like one of the other mistakes I did make while building it is I ended up getting a screw stuck in the E-bay in my early tests and had to cut it out, and ended up with this very awkward large hole in my upper body tube. Amazingly, it has no structural effect on anything, but I also do have a lot of extra holes around that shouldn't exist but do exist because of mistakes I made when building this rocket. But we have those. Mistakes happen. The E-bay also has fiberglass bulkheads on either end and 2 aluminum rods running through to transfer all the load. So none of the load from the ejection charges and parachutes are actually going through 3D prints. They're all going through fiberglass, aluminum, and steel. All right. Then we finally get to everyone's favorite part, the full lower body tube. So this is one basically giant fiberglass layup that I'm dealing with. I ended up doing the layup on the top the same way, like from the top edge of the fins to the top of the body tube, the same way I did the upper body tube. I just wrapped 2 layers around. I was originally talking about like trying to lay fiberglass down the center here. I found that was way too hard. So I just glassed right up to this edge, and then I did tip-to-tip layups on the fins that overlapped each other, and I sanded everything smooth. So if you like look at it from the side, you can see there's a slight thickness difference, but it's almost non-existent in a thickness difference between the 2 parts. Another thing that I mentioned earlier in the video, and then was something I found was a terrible idea, is that I wanted to do like an aluminum leading edge in like aluminum foil tape and then glass over it. I forgot that aluminum foil, or well, aluminum in general doesn't, like epoxy doesn't stick to aluminum, period. Epoxy rejects aluminum and pulls away. So the aluminum foil I ended up putting over these 2 edges ended up resulting in the fiberglass pulling away. Now, oddly enough, the fiberglass pulled away consistently across the whole thing, and we ended up with these really, really nice rounded edges. And then what I ended up doing was I drilled a handful of little portholes down each of the fin edges, and I filled the gaps with epoxy to ensure that it's actually a solid leading edge all the way down. But this is basically a continuous fiberglass layup all the way around. If you were to start on one fin edge and continue all the way around, there is no spot where the glass breaks. There is a continuous layup or pieces or layups of fiberglass all the way around. Now there are areas throughout the rocket where I left the glass texture rather than trying to fill it in or sand out the just texture the fiberglass had. Either areas where I was like a little dry on epoxy or a little wet heavy on epoxy, and I just really felt like that gave Festus some character. My lower rail button here is screwed just straight into the fiberglass and the 3D print underneath there, and it's a pretty orange rail button. I just really like it. And then I've got my thrust plate on the bottom, which worked out great to transfer all the load up to the body tube and keep extraneous forces out. One thing I have noticed is that from the ejection charges, when it blew this apart, there does seem to have been some light warpage inside the 3D print because the 3D print was so thin. So I'm going to have to do a little bit of sanding to free it up to ensure that everything will come apart smoothly for the next flight of Festus. Additionally, I added a camera to the outside, so you'll actually get to see some onboard footage of Festus going up the entire way. And then I've got it a little bit after nose over, I think is where I've chosen to cut off the film, the footage. 3, 2, 1. That did it. Oh, yes, baby. All right, gang, let's take a closer look at this. Okay, so this is what happened. 2 grams of black powder was a lot and it pulled pretty hard. Mild concern about potentially deploying the main early. As we can see, it started to separate a bit right there. I don't think it's actually enough of a jolt to pull my shear pins out, since I'll have shear pins in the bottom as well. But something to consider moving forward. It did pretty much perfectly lay out the shot cord, nose cone, everything was perfectly laid out. So that happens right at tip over. It will lay everything out exactly as I want it to.
And this is going on a J800. Hopefully he can find Matt Dillon. Okay, Jonathan's going to go in 5, 4, 3, 2, 1.
Woo! That was stable. Alright, so aside from this being an experimental test flight of a 3D printed rocket using some fiberglass stuff, it did have fiberglass layup, a lot of fiberglass layups over it, but like a 3D printed core. It's also the first time I'm using this. So, like, I had to use the egg finder. I literally finished building the egg finder Wednesday, something like that. Like, I'm flying something I literally just put together, and it's working great so far. Amazingly, I have track on it. A little nerve-wracking though. All right, I just got my first view of the parachutes. Actually, both are out, which is incredible. I can see them just over the horizon, and I just picked back up my GPS signal. Nope, lost it for a second. But there's little parachutes popping up on the horizon. I'm hoping I'll be able to get the footage good enough to look in at them. But the one that's really open, that's allowing me to actually see this right now, is actually a top flight that I got from our local science education center. He had them, bought them off some guy, and had them for really cheap. And like they're old school top flight, or not old school top flight, old school fruity shoots. Wow, they're old school fruity shoots. And
The pair was $100 for two 36-inch fruity shoots. The 2.2 CD variety, I couldn't pass it up. So they look to have flown great. And this thing has been incredible to use. The egg finder, literally with the GPS add-on, is just pointing me in the direction I need to go. And I just started walking that direction and then saw the two parachutes on the horizon dancing. So if the simulation was correct, we should have peaked about 5,000 feet. I think 4,700-ish will be a little more accurate. We'll see what the beeps say when we show up. Because the altimeter should be beeping, which probably means I'm gonna have to turn my tracker off because it's gonna be a lot of beeping going on. Sentimental towards my cert rockets, and a little sentimental towards Festus now too, but Festus is built to take a beating, so she's gonna take a beating. That beeping getting annoying to anyone else, but we're not turning it off because this looks like my rocket, but that does not mean it is my rocket. Oh, it's just beating the crap out of the... That's why I've been getting intermittent signals. The parachutes are lifting the nose cone up off the ground. The Dust Devil actually has it right now, which is kind of annoying. But it's just picking the nose cone up off the ground and floating it around. Oh, that's why I keep getting a little beep, beep, and it would lose it. I got no description for the scene in front of me, other than this is just rocketry life. Woo! Hello! That just came in behind me. Wow. Got a nice apogee shoot on it, buddy, but I just about got hit. And this is probably what's been happening to my rocket too here, where it's getting drug. So, hard part is looking at it. It's a cert flight, and I'm not allowed to mess with it. I'd really like to stop it for the dude, but I'm technically not supposed to. Like, your cert flights are your flights. Oh, hey, mine's running away too. Oh, this is why the distance has not been getting smaller. We landed in this really soft field, but the wind right now is, you know, somewhere around 10-12 miles an hour, and is dragging our rockets, which means mine's getting its paint job undone. His flew without a paint job. He's now getting a paint job and a nice core sample with this body tube. But we're probably gonna have to hang out here for a little while so I can keep an eye on his rocket, because he probably does not have a tracker on it, based on the fact that it's a plastic nose cone. But we are at Festus. That is our boy Festus. And as you can see, it's got quite a drag mark here. It's still dragging actually. So we're gonna put that to rest real quick by trying to block it some. 5,571 feet. Holy cow.
All right, so what you saw from the launch footage there and some of my commentary after during recovery is that there were a lot of things that in the field, as I kind of previously mentioned, didn't go according to plan. My tracker didn't work when I got out there. So I was using an experimental tracker, which is the egg finder that I just finished putting together 3 days prior to launch. And I brought it out there because I wanted to like test it, set it down on top of the truck, and then run around the field and see like how accurate the reading was and like could it take me back to where I wanted to go. Ended up that its first real test of anything, even before I actually finished the egg finder series that I'm putting out, is I had to go track a rocket rather than what my plan was to send my wife running around a yard and track her with it. I went and actually tracked a rocket with it first. I got to do absolutely zero ground testing. I just basically chose a prey method. I turned it on in the nose cone and walked around a little bit to make sure it was always pointing back at the nose cone when I did circles around the table that the rocket was sitting on. And it was always pointing back to where I needed to go, had a rough distance being correct, and so I was like, all right, that's good enough, we'll go with it. It's got a track on it. So I buttoned everything up and put it in the rocket. I was also flying on a new parachute that I had just picked up that day as well. So it was a 36-inch fruity chute with 2.2 CD, the annular pull-down apex type of parachute. Now, I've flown on these before. I accidentally ruined the other one we have during ejection testing, because ejection testing, I showed you one footage piece of the ejection testing, and that's all I showed you. And there was a lot more testing than that was done. That was just the first successful one. I really did not feel like making this video longer by showing you the dozens of tests it feels like I did just to make sure that ejection went perfectly on this rocket, since it was so weird to have a fiberglass tube sliding past a 3D printed thing, and then I was testing it with the shear pins in there to make sure that wouldn't add enough or too little resistance. Like, I started with like half a gram of black powder. It took 2 grams of black powder to blow this thing apart. That's pretty much it for the entire Festus build. Moving forward, I'm actually starting the whole level 3 cert process. So I've got my taps determined within Tripoli, 2 wonderful guys that I work with out at the Cloudbusters range all the time. And I'm going to be sending them my documentation here in the next month that I've built up on Festus and what I plan to do with the next rocket, which the next rocket is going to be named Praetor. It's going to be a purple gold scheme. It's going to be 5.5 inches in diameter, flying on a 75 millimeter RMS motor from Aerotech. I think it's going to be the M1356, 1354. I think that's the number. I'd have to pull up the model again, and I don't have that open at the moment. But Praetor is going to be almost 9 foot tall when completely finished, and flying on having a like 75 millimeter aero pack retainer. Like that is the diameter of Festus right now, is the motor I'm flying on. Like, it's a big motor I'm flying on, and I'll have a 5.5 inch diameter rocket, 9 foot tall, and it's basically a perfect scale up of Festus to the next size. So I've actually got a friend that'll be printing me the fin can. My fin can is currently made out of multiple pieces. There's like a chunk that ends here and a chunk that ends here, and then each fin is individually glued in before glassed. I'm gonna have it done as one print, and then I'll glass the whole thing up, just like I did for Festus. Festus also now has earned the right to have his name stenciled on the side here, so I'll be getting on that and stenciling the name on so that it's forever badged. Please consider liking and subscribing if you enjoyed this video. Thanks for watching. Now let's watch Festus break the sound barrier.